Hi, everybody, and welcome to this new episode of SageMaker Fridays, Season 4. I think this is episode number 9. My name is Julian, and I'm a dev advocate focusing on AI and machine learning. And as usual, please meet my co-presenter.
Hi, everyone. My name is Ségolène, and I'm a senior data scientist working with the AWS Machine Learning Solution Lab. My role is to help customers get their ML projects on the right track in order to create business value as fast as possible.
Thank you, Sego, for being with us.
Thank you, Julian.
So, where are we in this season? So, last week, we completed the automation segment.
Exactly.
And this week, we are embarking on the last 4 episodes, which are dedicated to a really cool topic, AutoML. Right? So, we're gonna dive into AutoML and learn what we can do with this technology. Okay, so today we are actually starting with a media / entertainment / web use case where we're going to try and predict clicks. Okay, so click prediction, pretty cool stuff. Before I forget, this is where you'll find the code for those last 4 episodes. They might, hopefully by the time you watch this, the code will be there. I still need to clean it up a little bit, but yeah, it'll be there. Okay, if not, you can ping me. Okay. All right. So let's start looking at our problem for today. So click prediction, right? Which really is a very common problem for, I guess, retail, media. You know, anytime you want to try and predict whether a customer will click on an item, right? It could be an ad, of course. The ad world is very eager to predict the right clicks. But generally, yeah, you have some content that's displayed. Okay, so again, ads or products or movies or songs, etc. And you want to figure out, if a certain item is going to get a click or not. Okay, so that of course you only show to your user the items that have the highest probability of getting a click. Okay, so very general problem, and we're going to frame this as a classification problem, right? Binary classification problem. So,
click or not click.
Yes, click or not click. So 0, 1. In fact, okay, obviously we get probabilities between 0 and 1. So we need a data set for this. And we actually found an interesting data set on Kaggle. You can see the URL here. It's a public domain data set. So thank you to the user who actually uploaded this on Kaggle. Pretty good stuff. It's rather big compared to our examples so far. It's about over 450,000 rows. So it's not big at all compared to the ad click data set. Usually those have millions, billions of lines. But hey, it's large enough to give us a challenge, and small enough that we can actually work with it today. Okay. So maybe let's take a quick look at the data first. So it's a CSV file. You actually get a training set and a test set, but we're only using the training set here. So yeah, we get 460 something thousand rows, 15 columns, and it's really what I think you would expect. So session ID for the web session, a timestamp, a user ID. So, who is the user actually viewing that piece of content? What product are we showing? Which campaign ID is this part of? What's the ID of the web page? And again, in your row log would probably have URLs and everything, right? So it's safe to say this has already been processed. Up to a point, right? So we know web page 13787 is whatever is on our website. Okay.
Yes.
Product categories, user group IDs. Maybe we have some user segments already. Gender, age range, and some other variables features that are not always super clear,
No,
right?
no.
But that's life. And of course, we have a label is click that tells us, 0, 1, no click or click. And as you would expect, we have very few clicks, right? So unbalanced data set.
Unbalanced data set.
Okay.
Can we show it?
Yeah, we can see. Yeah, so we can see some stats here. But yeah, if we want to see the label count, we can see it's about 7%, something like that. 7% clicks and 93% no clicks, which is actually very high. Because I worked in ad tech a century ago, and
not century.
Yeah, almost 2 centuries ago. Hi, if you're watching. And yeah, let me remove this. And it's typical to get maybe 0.1% click, right? Of course, we did better. But yeah, it's usually very, very unbalanced. Okay, so this is not such a hostile data set. Okay, so we can see, so an interesting thing is, what are those columns actually, right? So we see, campaign IDs, web page IDs here as integers. But these are kind of, placeholder values. These are really categories, right?
Definitively.
So if we were doing machine learning in the usual way, we will look closely at each column and figure out, is it useful at all? So session ID, it's certainly a unique ID, right?
Yeah,
so probably not much value here. Campaign ID, web page ID, product category. Again, all these are integers, but they're really categorical variables.
Categorical, yeah.
Right? So let's keep this in mind. And I'm sure, all you data scientists out there, you would go and start engineering features with this stuff, right? And it's actually a lot of categorical variables here. Okay, so not a very complex data set. And again, we could go and use our favorite algos. We could use XGBoost. We could use LIGBM. Lots of algos out there to build a model, classification model, right? But as
we are lazy today.
I'm lazy. No.
We are lazy.
I'm lazier. Okay. So yeah, we're getting lazier and lazier as we progress into the season. And so we don't want to build a model ourselves. Okay. We're going to look at a technique called AutoML. So before we dive into it, Sego, can you describe a little bit what AutoML is? Why do we even care? What are the use cases? And then we'll talk a little bit about how to do it on SageMaker.
Perfect. So, yes, this is what we have seen until now. Building machine learning model requires to manually prepare feature,
right,
test multiple algorithms, optimize hundreds of model parameters in order to find the best model for your data. And this approach, as we've seen, requires deep ML expertise. So if you don't have this expertise, it's not a problem. You could use an automated approach that is called the AutoML approach.
Okay.
Because in a nutshell, AutoML automatically prepare your data sets, try different machine learning approaches for you, and combine their results in order to deliver high quality models.
Okay, so basically we just bring the data.
We push the data.
Here's the data, go and figure it out.
Exactly.
And I get a model in the end. Okay.
That's it.
Right.
You like it that way.
Right. Oh yeah, the lazy guy in me loves this. Okay. So all joking aside, I mean, laziness is a virtue, as we know, but what are the real life use cases for ML? Why do ML teams look at AutoML?
So, of course, if you don't have any ML skills to build quality models, you will use AutoML. But after, the second option for AutoML is to help experienced practitioner analyze data and train model at scales.
Okay.
because for the expert, AutoML offers the potential of implementing best ML practices only once, and then after model selection, ensembling, hyperparameter tuning, etc.
Okay.
And then after you are able to repeatedly deploy them. So this is really the second aspect of the AutoML.
Okay, so if you have lots of data sets, lots of different models, if you have 5 people in the team and 200 problems to work on, I guess you could use AutoML to find the most promising ones quickly.
Exactly.
And then focus on those, and focus on the top ones.
Exactly. After you focus on the best one, and you can improve it.
Kind of filter your problems quickly.
Exactly.
If you get a decent baseline with AutoML, then it's worth spending more time.
Yeah, and it's gonna help you to scale without having manual intervention.
Yeah, and you can, of course, and you of course, I see what you mean. Yeah, you don't spend your time writing that feature engineering code and tuning code again and again. It's built into your AutoML tool, right?
Exactly.
Okay, interesting. Okay, so just to summarize, so we just bring in the data, right?
Yeah.
And then it figures out the problem I'm trying to solve.
It's gonna try to find.
Okay, interesting. It cleans and processes the data.
Yes.
Trains the model.
Yes.
And tunes it.
Tune it.
Okay, all right. Let's give it a shot. Okay.
And it works.
And we'll see.
We'll see.
We'll see. Yeah. I'm lazy but not stupid. Okay. I try not to be. Okay, I am sometimes. Okay, so SageMaker has an AutoML capability, which is called SageMaker Autopilot, which I think we introduced last season.
Yeah.
But we'll keep looking at it in those 4 episodes. And there's another tool that we're going to look at, which is an open source library called AutoGluon. We will look at it in a lot of detail next week, and I guess the week after that. Today we're going to focus on Autopilot. Maybe we'll give you just a quick taste of Gluon and how it differs from a managed service like SageMaker Autopilot. Okay, so let's get to work. So there are 2 ways to use Autopilot. We can use the SageMaker UI, SageMaker Studio UI, and of course we can use the SageMaker SDK.
But it will be just a couple of lines.
But it's very you'll see it's very little code. Okay, so I guess let's start with the UI. Okay.
Yes.
All right. So let's go, and so this is where you want to start. So experiments and trials, right here, and click. Maybe just give it a little space. Click on Create Autopilot Experiment. Okay. And this will be called Autopilot Click Prediction or something. Okay. We could create tags. We could add this to a project. We're not going to do this. So of course we need to. You promised I would only pass the data set, right?
Only
yes.
That.
Okay. All right. So let's find my bucket. All right. We need an output location for this training job. Okay. Let's use this. Select the machine learning problem type. So we could say auto.
Yes.
And then it will figure out if we're trying to do binary classification, regression, or multi-class. Okay. So that's totally okay. The only thing is if you do this, it uses the default metric, which I think is a validation accuracy. So instead we could say, okay, we know it's a binary classification problem, and why don't we use AUC as a metric? Okay.
Perfect.
All right. Do we want to run a complete experiment? So yes, here we want to go all the way to tuning. You could only ask for basically the analysis step and the generation of notebooks, which we'll see in a few minutes. Okay, but let's go all the way. You could also auto deploy the best model. So let's not do that. Okay, and of course we have extra settings for permissions, encryption, VPC, etc. Okay. which we won't touch. And finally, we just click on create experiment. Okay. And off it goes. Okay. And we have a very nice 90-70 vintage animation. Yes. Amazing. More importantly, we see the different steps. Okay. So as you would think, pre-processing. So looking at the data set, figuring out what those columns are, and what kind of feature engineering steps to apply, and what to try. Because of course, Autopilot is going to try different things. Okay, and this is what candidates are. Candidates are basically, hey, I've got this idea. I've got this idea of feature engineering plus training. Okay, let's go and try this. Let's do one-hot encoding plus blah, 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 and then use XGBoost. Let's do one-hot encoding plus something else and use neural networks, etc., etc. Yeah. So it's going to generate different pipelines. Then it's going to apply those pipelines to our data set. Okay. So it's going to create multiple copies of the initial data set. And then it's going to actually train and tune, so launch for each of the candidate pipelines, launch a hyperparameter tuning job, okay? And by then, yeah, we'll start seeing models. And finally generates an explainability report with SageMaker Clarify, which we covered a few episodes ago, okay? So we'll leave this one running for now. As you can imagine, it takes a little while to do all of this, and I already completed a job. So let's take a look.
But after, when we see that it's kind of as well of automation, because all the steps of the ML process are automated as well.
Yeah, so that's it. We're done. We're absolutely done. So
last week we did some. Automation manually,
yes,
and now everything.
You're right. Yeah, it's it's absolutely similar. We have automation all the way, and we will actually see that we get access to that code, right? So let's leave this one running for a little while, and yeah, we'll come back to it, and hopefully, it makes some progress. Okay. All right. Fine. So let's time travel to the end of the job, okay? And once pre-processing is done, all right. So once we've analyzed the data, once we've come up with the pipelines, we actually get access to those auto-generated notebooks, okay? And this is a completed job, and you see those two links here. Okay, so we can read a data exploration notebook and a candidate generation notebook. Okay, all right, and again, this is available as soon as pre-processing is done. Okay, so let's look at those notebooks. So the data exploration notebook is basically, I would say, basic stats on the data set, right? So nothing, nothing super fancy, nothing that you wouldn't do yourself. But I guess
that's still important to do.
Yeah, it's still important, at least as a sanity check. Okay, just to check that. Okay, this is the data that this job used, and yeah, this is really what it looks like, and missing values are what they should be, right? So we see there are a couple of columns that are a little bit empty, right? So hopefully we have some imputing logic to in the pipeline. We'll check. Some stats, right? Number of unique entries. Okay, is click obviously 0, 1. We see 7 age levels and 10 products and 10 campaigns, etc., etc. Yeah, and we see session ID is actually equal to the number of rows. So that's a very useless, very useless column, right? We can
see that there are different user ID who connect.
Yes, and we have different displays. For the same user, probably. Yeah. Okay, so again, nothing extraordinary, but it's good to have that just to get a quick sanity check on the data.
But we can see as well that campaign and web page idea are still seen as a numerical value.
Yes.
Here.
Yeah. So yeah, they're analyzed as numerical value. So, but I guess it's the data set description. So, but you're right. We need to check in the feature engineering code, what decision Autopilot took. Does it consider those columns to be integers, or does it consider those columns to be categories? We'll see. Okay.
Wait and see.
All right. So now let's go to the more interesting notebook, which is this candidate definition notebook. So this is where we see the decisions that Autopilot has taken. Okay. So there's some setup code here, which you can skip. And by the way, this is a notebook and you can run it. Okay. So here it's a read-only copy that I opened. When you click on here, it's you just get a read-only copy. But if you import it, then it copies it from S3 to your SageMaker Studio instance, and you can edit it and run it. Okay. And the cool thing is, of course, you can replicate the AutoML job. There's a lot of discussion on AutoML is a bit of a it's hard to understand what happens. We got a model, but how do we know how this was built? Well, now we know, right? So it's I call it open book AutoML, because you can see the feature engineering code, you can see the training code, you can see the tuning code, and you can run it on your own. Okay, so you can actually run all those things yourself. Okay. All right, so now we're starting to see some of the pipelines. Okay, so pipeline 0 is, we transform numeric features using robust imputer, categorical features using threshold one-hot encoder, datetime features using datetime vectorizer. And then we scale everything, and then we train with XGBoost. Okay, and here we see some setup code where, if we wanted to train this again on bigger instances or smaller instances or differently, but we could do it. Okay, it's just technical code. The important bit is this description here. This one is doing
quite the same.
Yeah, it's doing the same, except it's applying a PCA.
PCA,
before scaling. Why not? It's still doing XGBoost afterwards. This one is trying linear learner, so linear regression, which is another algo supported by Autopilot. This one is doing something a little different again with XGBoost. Another one. Another XGBoost combination. Another XGBoost. Do we see an example maybe of... Oh yeah, okay, here it is. So MLP is multi-layer perceptron, so feed-forward neural networks. Okay, which is also supported by Autopilot. So we get those 10 pipelines. Okay, so as you can see, a combination of feature engineering and algo selection.
So different ingredients and different recipes.
Exactly, different ingredients, different recipes. Good summary. And again, we could we could run all this stuff. We could run one pipeline only if we wanted. Okay. And then we can launch tuning. Okay. And here, as we actually use 3 different algos, right? XGBoost, linear learner, and neural networks. We actually use an advanced feature in SageMaker, which is a multi-algorithm hyperparameter tuning. So we've done tuning before on a single algo, but you can actually launch jobs for different algos, right? But again, all this code is generated for you. We can see the hyperparameter ranges, etc., etc. Okay, and then you just launch it. Okay, and this really is equivalent, or I should say identical, to the job we are running now. Okay, so you can replicate the job, you can understand how it was built, you can explain how it was built, and you can tweak. You can keep tweaking, right? So if you have further ideas, if you want to modify the pre-processing code, you can do that. Run the notebook again. So I think it's pretty cool, right? Okay, so let's take a look. Where's our job now? Okay, Here it is. Okay, it's still pre-processing. Okay, because it's really the bigger, the bigger part of the job. Because we need to do this. We need to do this a few times, and it's a lot of data, right, that we have. Okay, we'll keep checking on this guy. So can we see the code? Because we see the tuning code, but can we see the code for those data prep steps? And the answer is yes. Okay.
Where?
So if you click on this, and it does nothing, but there, it's just a shame. But you can actually see in your browser, you can see the path, the S3 path. So if you go in the output S3 bucket for the job and look for candidate generation, etc., you'll find it. So I copied it. Yeah, candidate data processors is what you're looking for in that output location. And I just copied that bit because there's a lot of information there, right? You see, you have all the training splits, the validation splits, because of course Autopilot will split your input data set as needed. You see all the pre-processed versions, so lots of stuff. But you can also see those pipelines, those pre-processed. So let's look at maybe number 9, right? Yeah, this one. Let's take a look. So that's the actual Python code. Okay, and these are based on transforms that are super similar to sklearn transforms, and this is actually available on GitHub, right? So if let's see if I'm lucky. Yes, okay. So if you go on GitHub, you'll find this repo here, and you'll find the code for those transforms, pre-processing. Right, it's all in there. Impute. Okay. So if you're curious exactly what this code is, it's on GitHub, right? So we import that, and then we have pre-processing code. Okay. So we see some columns are treated as categorical. Product category, gender, edge level. Makes sense. Some columns are treated as numerical. So you could argue, campaign ID, web page ID, should they be categorical or should they be numerical? My opinion is they probably need to be categorical. But then again, you have the code. So just change the code, upload it back to S3, run the pipeline again, and you'll see if it makes a difference, right? But here, the decision that Autopilot took is this one. Okay, and then it creates the different steps. So ordinal encoder, robust imputer to fill in missing values, vectorizer for date and time, etc., etc. And then it combines everything into a scikit-learn pipeline, because that's really what it is. And this is what is run. Okay, so again, open book stuff, right? And this is really stuff that you would write yourself. But you can go and reuse the code, you can tweak it, you can learn from it, or criticize it. But the good thing is it's there.
Yeah.
Okay? It's visible.
And it's really a gain of time.
Yeah.
You see that.
Yeah. And you can see it's not a lot of code here. Right? And maybe look at this one here. See if we have some differences, different objects, but again, same logic, right?
Different transformations.
Different transforms. Okay. So once we launch the job, we go through each step, okay? And as we hit the tuning step, we start to see some jobs, okay? And we'll probably start seeing jobs in the other example in a few minutes. Okay, we'll make sure to show that to you. But you'll start seeing tuning jobs appear. Okay, and again, these are all the tuning jobs coming from those 10 pipelines. Okay. And I think by default, we run 250 jobs, 50, right? So 25 jobs per pipeline. Okay, so each of those jobs, you can go and open, okay? And each one of those is a training job, okay? And we can see, okay, that's the original input data set. We can see where the splits are. We can see what actual transform data was used. So this is one of the jobs from pipeline 1. We can see this feature engineering code. We can see the feature engineering model that was used for to transform features, and we can see the actual model that was trained. Okay. So again, you have access to, if you want to inspect particular jobs, you can see everything here. And of course, at the end of the day, after maybe an hour or something, the job is complete. And needless to say, all this stuff runs on managed infrastructure, right? We didn't even say it because by now this should be pretty obvious. We didn't configure anything here. And so we get the top job, which is this one, right? With an AUC of 0.60, which is, I would say, on the lower end of what we would consider okay. But it's the baseline.
Yeah, it's the baseline.
It's the baseline. This tells us, there is something there. Okay, there is something there. There is some predictive power in this data. So, maybe this is a good place to start. Okay, and of course, we can do better than 0.6. Okay, and hopefully, but this is a good starting point, right? Given how little effort we've taken here, just literally, clicking in the UI and getting a job, this is what we get. And this is a reasonably difficult data set, I must say. It's okay, so we have this top job. We, of course, again, we could inspect it. We see this is an XGBoost job. We get all the artifacts information here. And we see the feature importance report from Clarify. So web page ID is the most important one. Session ID really shouldn't be there. No. It should have been dropped. Okay, so probably we should drop because it's a meaningless value. So we should remove it and help XGBoost figure out that this isn't really important. Date, time, campaign ID, product, etc. Okay, and of course you can get a full report if you want to. Okay, but we've covered Clarify in a lot of detail already. Okay. So next we could go and deploy the model if we wanted. Okay, so we could deploy it on an endpoint. We've seen how to do this a while ago, and you would just give it a name, right? Why not do it? Click endpoint, M5XL. Do we want to set up data capture? Remember we discussed SageMaker model monitor. So we could configure this thing here. And we just say, all right, go and deploy. Okay. And in a few minutes, we'll have this endpoint and we can go and test it. All right. So how much code did we write?
3 lines, 4 lines, 5 lines?
Zero. Well, we really wrote 0 lines, right? I did everything in the UI.
Yeah, you did everything.
Of course, we wrote some code here to show you the data, right? Which you could probably go and look at with Data Wrangler and maybe do some transforms, drop some columns.
Yeah, but I won't do.
Again, we've covered Data Wrangler in a lot of detail earlier, but we really wrote no code at all. Okay, which is fine. So this is really how you can build and deploy your model with Autopilot and Studio and no code. Okay. So now let's see how much code we would write if we use the SageMaker SDK.
1 line.
1 line? Yeah, you're pretty much right.
2.
You're pretty much right. Okay. All right. So we load the data set. We do some descriptions here. All right, that doesn't count.
Yeah. Okay.
So the data set needs to be in S3, but it's already in S3 because everything's in S3. My life is in S3. So that doesn't really count. And okay, that's 1 line. So we create an AutoML job. This is the SageMaker IAM role for permissions, S3 access, SageMaker access, etc. Which is what's the name of the label?
Label, yeah.
What problem type are we covering? And again, you could say auto and be done with it. But here I want to use AUC, so that's what I'm using. And max candidates 250, I think, is the default value. So we could probably, it could really be as easy as this.
Yeah.
That's it.
That's
So
it.
you don't need to be a software engineer, right? And then you call fit, passing the location of your data set in S3. So 2 lines of code, right? 2 simple lines.
So it's very simple.
And then you get the same result, right? You get the same result. So let's take a look and see if we may.
Which one do you prefer? SDK?
Which one do I prefer? No, I prefer the SDK. Sorry, I was born in the I was born in the 70s. I'm a terminal kind of guy. I use VI. I use I type with 2 fingers. I love the green on black theme. Yeah. Sorry. What can I do? More power to all you guys with super fancy IDs, but I'm Jupyter for me is kind of state of the art. Okay, all right. Who cares? So we have a few minutes left, and at the beginning of the episode, we mentioned this other tool called AutoGluon.
Yes.
Okay, so it's an open source library. Okay, let me show you maybe where to find it. Yeah. So AutoGluon is actually it's a couple of years old, I think.
Yeah.
It's an open source project started by Amazon teams. You can read the research paper on archive, and I would actually highly recommend that you read it. Sometimes those are super math heavy and difficult and obnoxious. Can I say that? Yeah. And because I don't understand what they say, so I feel really ashamed. But this one is very good and very readable. Okay, it doesn't. Clear. I don't think it has very little math. You can really skip it. But it's a super good intro to AutoML and the design decisions. And AutoML versus hyperparameter tuning. There's a good study on the different AutoML frameworks out there, still very relevant. So I really recommend that you read it. I really enjoy this one, and I don't say that very often with the research papers. Of course, the code is on GitHub, and this is why is it called AutoGluon? Simply because it's based on Gluon, the Gluon API, which is part of Apache MXNet. Okay, and so what can it do? It can do AutoML on tabular data, similar to what we have, text, so some NLP use cases, and computer vision, right? It does pretty interesting data processing automatically, and what I really like about it is it has a pretty big collection of algos. So you can do linear regression, KNN, lots of tree algos. So of course XGBoost, LightGBM, CatBoost, extra trees, and a few more, and deep learning in a pretty clever way, which is more advanced than plain feed-forward networks. We will go into more detail next week, and particularly it's really based. The reason why AutoGluon really shines, I think, is it has some clever ensembling techniques. Okay, so again, we'll talk about ensembling in detail. But in a nutshell, ensembling means train lots of different models and combine them in clever ways to make them smarter and to generate better predictions, right? So, unity is a strength, right? In a way, yes, of course. So that's pretty good. Very interesting, and it's again just 1 or 2 lines of code. Okay, so now you want to see it, right? So okay, let me. We won't look at the example in detail, but just give you a sense of what AutoGluon is. Okay, so of course you need to install it, and this is the same data set, right? Let's zoom in maybe a bit. Same data set, upload to S3, same code. Okay. And so import the tabular dataset object, which is how we refer to our data in S3, and we can read straight from S3. Tabular predictor, which is how we train and predict. Okay, so here I'm going for the full data set. So we'll dive into this a little more in future episodes, but of course, AutoGluon can infer the type of your columns, and it makes it also easy to assign your own types.
Okay.
So for example, here we can see a lot of variables are actually, a lot of columns, sorry, are actually picked up as integers or floats, but I could actually pass a schema saying, no, I want product category 1 and 2 to be categories.
Campaign idea.
Yeah, so it's yeah, exactly. And like, it's actually mostly categories, right? Okay, and now I've got my categories set right. Then I create this predictor object with the label and the evaluation metrics. And there's a wide choice of metrics, which is really cool as well. And then we just call fit, passing the location of our data in S3, a time limit, right? If we want, well, you can have no limit. How to train? Do you want best quality? Do you want fast inference? We have again a bunch of options we'll look at. Okay, here I'm passing my actual schema. I can exclude some algos. Okay, so I've got nothing against KNN and FastAI,
Yeah,
but just to show you,
okay.
just to show you how to exclude stuff. Okay, again, we'll dive into this in detail. So, and then we see, pre-processing, and then we can start, and we see some job being trained, and we see bagging. Yeah, bagging, very cool technique. We'll talk about that next week. Ensembling. Okay, and we see level 1 models and level 2 models, so that means we have stacking. Again, we'll talk about stacking next week. Okay, and it's actually still running, right? But we see, and it actually stops by default at level 3, so we'll have 2 layers of models in the final prediction. But we can already see at level 2 that we have really good AUC, right? We're already, we're 0.65. We're probably going to get close to 0.7 when it's by the time it's done. We can print the leaderboard, etc. So we can see, we get significantly better results than autopilot, and it's probably because we have I would say, wider range of algos, and more than anything, we have ensembling techniques, which are really, really powerful. Okay. So we'll look at that next week. We'll look at, here I'm running this stuff in my notebook. We'll show you how to run this in a SageMaker job. Okay, so much more coming. Okay, but we're almost done. So looking at the job we started, we see, pre-processing is done. Candidate definitions have been generated. Now it's engineering features, so it's applying those 10 pipelines to the data set, and then it goes into tuning. Okay, and this runs for about an hour. Okay. So we won't wait to see that, but you saw the final result. Okay, so
time to wrap up.
Yeah, time to wrap up. So what can we say? AutoML
is powerful.
Is interesting.
Is interesting.
If you don't like writing machine learning code, it's great.
It's great.
If you want to experiment with different algos quickly, automatically, it's very good. It's very right. Good. And still, you can exactly understand what's going on, right? You can get full visibility, and you can keep tweaking, right?
That's good.
And so, if you want to go the managed way, autopilot is really the way to go. It's the simplest way. If you want a slightly more do-it-yourself way, AutoGluon is very interesting. And again, with those ensembling techniques and other techniques we'll discuss, we'll see we can get really good results with really 2 lines of code. Okay, and if we wanted to run 100 jobs in parallel and do something else while it trained, then we could do that. Okay, so the scaling effect with AutoML is very interesting, I think. All right, I think that's the end of this one. Segur, thank you very much.
Thank you.
I hope you found this first episode on AutoML interesting. We have 3 more. And they'll just get crazier as we go. Okay, we'll want to end this season in style, so bear with us and stay with us. And until then, have a great week and see you soon. Bye bye.